Dear students, welcome to the next concept. So, on the basis of this concept, you may get direct questions. They are going to ask the question directly. So, standard questions, remember intensity of electric field at any point on the axial line of electric dipole. Remember, this is electric field due to dipole on the axial line. Consider a dipole of dipole moment P equal to Q into 2A. You know very well. So dipole moment is P equal to Q into 2A. Dipole moment is direction from minus Q to plus Q. So length of the dipole is 2A. So midpoint I am taking A and A. What is meant by axial line? Imaginary line passing through the two charges. This imaginary line, these are the two charges. So if you imagine one line, horizontal line, this imaginary line passing through the two charges is known as axial line, this horizontal line. Consider a point capital A on the axis which is at a distance r from the center of the dipole. Distance r, point A which is at a distance r from the center of the dipole. Now this is A, this is small a. So what is the distance of this point A from plus Q? See, this total is R, the small value is A, so baki remaining is R minus A. What about the distance of minus Q from A? This is R, extra is A, total is R plus A. Now, at this point, electric field, I want to find electric field. Who is giving electric field at this point A? Point charge plus Q will give electric field. Point charge minus Q will give electric field. So let me find out electric field due to positive charge. See, electric field due to plus Q at A. So I told you this is point charge. Electric field due to point charge is, I told you already, 1 by 4 pi epsilon naught. Electric field due to point charge is 1 by 4 pi epsilon naught Q by distance square. This is the electric field due to point charge. Already I explained this derivation, remember. So this formula I am applying electric field due to positive charge at A. So this is 1 by 4 pi epsilon naught Q by distance square R minus A whole square. R minus A whole square. Check it carefully. Electric field is vector. So electric field due to positive charge is away from it. I told you already, electric field due to positive charge is away from it. So E1 is away from capital A. See this arrow mark, very important. Electric field due to negative charge at point A, that is I am taking as E2. Same point charge 1 by 4 pi epsilon naught, distance is more, it is R plus A whole square. Electric field due to negative charge is towards it. Arrow mark dekho here, E2. So here E1 and E2 both are opposite. So two vectors are opposite. So resultant will be, we have to subtract these two, you will get resultant. Sir, in this E1 and E2, I am going to subtract. So who is more, who is less? Check it. R minus A. Distance is less. So automatically electric field will be more. Distance R minus A, electric field will be more. E1 will be more. R plus A, distance is more. E2 will be less. That is why while finding resultant, so we have to subtract more value minus less value. E1 is more, E2 is less. That is why resultant will be in the direction of higher value. Resultant will be in the direction of higher value. E1 is more, resultant is in the direction of E1. So which is named as electric field on the axial line. So now I am going to subtract these two. Very simple calculation. So E1 minus E2. Resultant electric field is E1 minus E2. Substitute E1 value, E2 value, above values. So take the common here. This is the thing, LCM you can take. So here this thing you have to understand. A plus B whole square minus A minus B whole square. So A plus B whole square, mathematics, A minus B whole square model. This is equal to 4AB. You will get it. Otherwise here also you can expand A plus B whole square minus A minus B whole square, expand, you will get the same thing, 4RA. Here I am just modifying one thing, just 4RA I am rearranging it. So 1 by 4 pi epsilon naught. In this 4 I am writing 2 outside, another 2 is pending. Q I am taking here. Here 2A I am writing like this. R I am writing outside. Check it. Q equal A. Okay. R is there. 2 into 2 4. So just this step you have to understand. Rearranging this value like this. So 2 of Q into 2A. So Q into 2A is nothing but P. So this is nothing but Q into 2A, bracket value is nothing but P, dipole moment. So now if you see, this is equal to 2PR, 1 by 4 pi epsilon naught to 2PR by R square minus A square whole square. So this is the electric field, long dipole, so length is thoda more, so this is the electric field. So here electric field vector quantity, what is the direction of electric field here? Check it, see the diagram here. This is the direction of dipole moment, this is the direction of axial electric field. Arrow marks dekho, both are in the same direction. So this sentence is very important. Electric field on the axial line is parallel to the dipole moment. Electric field on the axial line is parallel to the dipole moment. That means minus q2 plus q, like this. Electric field will be like this, minus q2 plus q. For short dipole, length is very small, A is much less than R. Short dipole, that means the length of the dipole is very small. So A is much less than R. So A square will be very much less than R square. So in this formula, small value I am neglecting here, A square I am neglecting here. So if you neglect A square, you will get R square whole square. So R square whole square like this, R power 4. One R will cancel here, 3 is remaining. So this is the value 2p by R cube. Most of the cases they will mention short dipole, many cases. So remember, this is the general formula, long dipole, and this is for short dipole. And we will see the electric field on the equatorial line in the next concept. Thank you.